Hi, I'm Detective Incognito, and I explore events that challenge what we know about our current world. What you're about to hear will change the way you see life. Welcome to another investigation. 2024. A major tech company rewrites its hiring algorithm from scratch after discovering gender bias. New code, new architecture, new training process. The engineers deploy the updated system, confident the problem is solved. Within weeks, the same bias reappears. Women candidates rank lower for technical positions despite identical qualifications. The anomaly persisted through complete code rewrites, multiple iterations, different frameworks. UNESCO reported that 89% of large language models exhibit gender stereotyping. Even after correction attempts, women associated 4 times more, frequently with home and family contexts than professional ones. If you want to understand why AI bias survives code rewrites and what this reveals about machine learning, subscribe to this channel, because what engineers discovered challenges assumptions about how artificial intelligence learns and whether bias can ever be fully eliminated. This is the story of the anomaly that wouldn't die. Engineers at a prominent technology firm discovered their resume screening system systematically downranked women applicants in 2020. The bias was clear in the data. Identical resumes with female names received lower scores than those with male names. The company response was immediate and comprehensive. Delete the biased system, build a new one from scratch with explicit fairness constraints. The new algorithm incorporated bias mitigation techniques developed at leading universities: adversarial debiasing, fairness-aware learning, demographic parity constraints. Engineers tested the system exhaustively before deployment. The metrics looked perfect: gender-neutral scoring across all test cases. Then real-world deployment began. Within 30 days, patterns emerged. Women applicants again received systematically lower scores, not as severe as the original system, but statistically significant. Engineers were baffled. The code was completely different. The bias mitigation was state-of-the-art, yet the anomaly had returned like a ghost haunting new machinery. Researchers suggest this wasn't a coding error, but something deeper. The team investigated whether the bias mitigation itself created problems. Studies from MIT and Stanford had documented a troubling phenomenon called bias amplification. Sometimes, attempts to correct bias in AI systems actually make it worse. The mechanism is counterintuitive. When engineers add explicit fairness constraints, the model may learn to associate protected characteristics with those constraints, creating new subtle biases while eliminating obvious ones. A hiring algorithm told not to discriminate by gender might learn that gender is important precisely because the constraint exists, similar to how telling someone not to think about elephants makes them think about elephants. The system learns gender matters by the fact that rules exist about gender. Columbia University researchers documented cases where fairness interventions reduced accuracy for the very groups they aim to protect. A model constrained to give equal outcomes sometimes achieved this by being equally bad at evaluating everyone in protected categories. The perfect fairness metrics hid deteriorating performance. The company tried a different approach: train only on anonymized data with all demographic information, removed names, pronouns, education, histories that might reveal gender. Surely bias couldn't persist if the model never saw gender at all. Did the system learn proxy signals? Gaps in employment history correlated with parenting, certain volunteer experiences, schools with historically gendered enrollment. The model reconstructed gender from fragments, and the bias returned. Studies indicate removing explicit information doesn't eliminate learned associations. The root problem wasn't code, but data. The training dataset contained millions of real resumes and hiring decisions from the past 50 years. That historical data encoded decades of workplace discrimination. Even perfect, unbiased code trained on biased data learns biased patterns. The data showed that historically, certain resumes led to hiring and others didn't. The AI learned those patterns faithfully. The model wasn't malfunctioning. It was accurately learning discrimination. From human history, UNESCO's 2024 report on gender bias in large language models revealed this problem operates at massive scale. Researchers tested leading AI systems, from Chat to Claude to Gemini. 89% exhibited gender stereotyping. Women associated with domestic contexts, men with professional and leadership roles. These weren't bugs in individual systems, but patterns learned from internet, training data reflecting societal biases accumulated over decades. Researchers at University of Washington demonstrated that biases persist, even when models are fine-tuned on carefully curated, balanced datasets. The initial pre-training on broad internet data creates associations so deeply embedded that subsequent training cannot fully overwrite them. The weights carry forward biases like genetic memories, surviving through generations of model updates and architecture changes. Companies now face an uncomfortable realization. You cannot fix biased AI by rewriting code if the training data encodes historical discrimination. 3 approaches emerged from research. Collect fundamentally different training data representing ideal outcomes rather than historical ones. This requires imagining what unbiased hiring looks like and creating synthetic data matching that vision. Second, use adversarial methods where one model tries to introduce bias and another tries to detect and eliminate it, creating evolutionary pressure toward fairness. Third, embrace transparency. Rather than claiming systems are unbiased, document exactly what biases exist and how they manifest. Allow humans to make informed decisions knowing the system's limitations. Google implemented model cards documenting known biases. OpenAI publishes system cards detailing failure modes. The EU AI Act mandates bias documentation for high-risk applications. Scientists still debate whether truly unbiased AI is achievable, or if the goal should be understanding and managing bias rather than eliminating it. The question isn't whether models will be perfect, but whether imperfect models can be deployed responsibly with appropriate human oversight and accountability. Structures. The anomaly that persisted through code rewrites revealed something profound. AI doesn't learn from code. It learns from data. Engineers write the learning algorithm, but the model's knowledge comes from patterns in training examples. Those patterns reflect the world that created them, including all its biases and inequities. When 20th century hiring data trains 21st century algorithms, the discrimination persists digitally even as society evolves. The challenge isn't technical, but philosophical. Do we want AI that reflects the world as it is, or as it should be? Models trained on reality learn historical bias. Models trained on idealized synthetic data may fail to function in actual environments. The tension is unresolvable without societal consensus on what fairness means and how to measure it. Different cultures, different eras, different communities have different definitions. An algorithm cannot be bias-free when humans disagree on what bias is. Perhaps the real lesson isn't that the anomaly returned despite rewrites, but that it revealed something always present. The bias wasn't in the code. It was in us, reflected back by the mirror we built. If exploring how AI amplifies human biases and why technical solutions alone cannot solve social problems fascinates you, join this journey. Because studying persistent anomalies teaches us that artificial intelligence doesn't create bias. It reveals and perpetuates what already exists in the data we feed it, challenging us to confront not just how we build systems, but what kind of world we want those systems to reflect. If you liked, subscribe to the channel, like the video, and activate the bell. Leave your opinion in the comments to let me know what you thought. Thanks for sticking around, and see you in the next video.